So first we would be discussing the problem number 1, which was TCDR. So basically the question was an easy question. Basically what the question said was, you are given a string S and you just need to remove A, E, I, O, U from it. And whatever elements would be left, you need to print those elements, right? So if we go to an example, so let's say Atcoder is there, right? So from Atcoder, you need to remove the vowel letters, right? So we need to remove A, we need to remove O, we need to remove E. So A, E, and A will be removed, O will be removed, E will be removed, right? So TCDR would be left. This is just a straightforward problem. Anyone have doubt in this problem? Please unmute if you have a doubt in the problem. And let me share the code also with you, this problem. So the code was just simple. We just inputted the string, and after inputting the string, we are just checking if the letter is anything among the vowels like A, E, I, O, U. If it is among those, we are continuing, or we can say we are not taking that letter. Otherwise, we are appending it in our answer string, right? And then just returning the answer, right? So anyone have a doubt in it? I guess I'm audible to all of you, right? Yeah, okay. So let's proceed with the second question then, if no one has doubt this question. So the second question said that there are n cups of ice cream. Now each cup had a flavor and a deliciousness, right? So Fi is denoting its flavor and S of I is denoting its deliciousness, that how delicious it is. And it is also given that S of I is an even number. Now, what the question is saying, you need to choose any 2 cup out of those n cups. You need to choose any 2 cups, right? And let's say the deliciousness of those 2 chosen cup is S comma T, and we are taking S as greater than equal to T. So, let's say if you choose 2 cups, then one of them will be having more deliciousness as compared to the other one, right? So S is representing the bigger one, and T is representing the smaller deliciousness one. So they are saying, if the 2 cups which you have chosen has different, because since each cup has deliciousness and each cup is having deliciousness and deliciousness and flavor, right? So if the flavor is same, in that case you need to choose S plus, you will get S plus T by 2 satisfaction. And if they are of different flavors, then you would be getting S plus T only, right? So is the question clear to everyone? What the question is saying, you have n cups, each will be having a flavor and a deliciousness, right? Each is having a deliciousness. Now the question is saying, so it is saying that you need to choose two cups, right? Now you choose 2 cup. So let's denote it's let's F1 comma S1 and F2 comma S2, right? So its deliciousness is denoted by S1. The deliciousness of another cup is denoted by S2. The flavor of F1 and F2. So if they are saying, let's say the chosen cup, if F1 is equal F2. So in that case, what they are saying is, let's say S1 is greater than equal to S2. So in that case, what they are saying is, you need to return S1 plus S2 divided by 2. And since all the S are even, so it will this number will also be even. This number will also be an integer. And let's say if F1 is not equal to F2, in that case, they are saying that you just need to take S1 plus S2. So is the question clear to everyone? Right? Just anyone unmute and say yes or no.
Yes, sir.
Okay. So basically, how we will proceed in this question is, so our basic goal is to maximize our satisfaction level, or in order to maximize our score, right? So the first thing or greedy approach which will come in our mind is, let's take those 2 cups which have maximum deliciousness, right? So if you go by this approach of choosing maximum deliciousness, in that case, what will happen is there exists two possibilities, right? One, that F1 is equal F2, and another is F1 not equal to F2, right? So let's say if this condition is true, that the two maximum cups who is having the maximum deliciousness have different flavors. In that case, we will have a correct answer, right? Because in that case, you will be having S1 plus S2, and we have already taken S1 and S2 as the two maximum. So we will be getting a maximum answer. But what if F1 is equal to F2? Let's say if the array has, let's take the sample only. So for example, in this case, the sample is 1, 4, 2, 10, 2, 8, 3, 6, right? So if we choose the maximum 2, then we will be getting, if we choose the maximum 1, then we will be getting 10 and 8, right? So what the sample is saying that 1 is 1, 4, another is 2, 2, 10, 2, 8, and 3, 6. Okay. 1, 4, 2, 10. 2, 10, 2, 8, and 3, 6, right? So if we go by the maximum, right? So this 10 and this 8 is maximum, right? But if you choose those two, so since their flavor is equal, so in that case, you will get an answer of this, right? But let's say if this was not 8, and let's say this was 4, right? Then if you choose the two maximum, like 10 and 6, then you will be getting 10 plus 6, 16, right? So we wanted to choose the maximum one, but the flavor is giving us a constant. So basically what I did was, you need to choose two, right? So first of all, maximum will always be chosen, right? Whatever the maximum is, we will always choose, right? Because it never gets divided, right? This 10 always remain intact, right? Here also it remain intact, and here it also remain intact. So I know, see, let's choose the maximum guy, maximum delicious one, right? And so 10 would be chosen. Then I'm saying let's keep its index also, like at which index we found it, and similarly let's keep its flavor also, right? What was its flavors, right? Now I need to choose another person, right? So now what you will say, you will now for the second person or the second cup, I have two candidates, right? Either a maximum of different flavor, right? Or second maximum. Second maximum means like let's say if there are 10 present in the same flavor, then the 10 will only be selected. And let's say like let's say 2, 10, 2, 8, and 2, 7 is present. So second maximum, right? Second maximum of same flavor. So I'm saying the maximum, first we will choose the maximum deliciousness one. Then what we will do is we will look for two things. First is we will choose we will find the maximum of different color. So if we different flavor, right? Let's leave the flavor of the maximum guy. Then we will choose the maximum guy of another flavor. Similarly, we will also choose second maximum of the same flavor. And then what we will do is we will just compute the answer of each of these two, and we will just check which is the maximum, right? So if you will go with, let's say, S2, we get S2, and here we get S3. So in that case, and let's say S1 was maximum, right? So if we go by this part, we will get S1 plus S2. And if we go by this one, sorry. So if we go by this one, since this is of the same flavor, so we will be getting S2 by 2. And if we go by this one, we will be getting S1 plus S3. So we will just need to check which is the maximum among these. Is the logic clear to everyone? Any doubt? Just anyone say yes or no, so that I can move to the code. The logic is clear, right?
Yes.
Okay. Okay, then let's move to the coding part then. Yes. So as I said, our first goal is to choose the. Okay, we started discussing the third question first. That's a mistake from my side. Sorry. So first, let's end up the third question, then we will go to the second question. Okay. So, and no one told also, right? That is the second question. Third question. Okay. So basically, what we are doing is we are just first finding the maximum element, right? And we are also storing its index. So the code from line number 14 to line number 19 is doing the similar thing, right? What it is uh, doing is we have just taken a variable s of I, highest, and we have given it an initial value of -1, right? Now what we are doing is we are taking the input and we are saying that if s of I is greater than highest, then highest is equal to s of I. This is just a standard method of finding the maximum element, right? And we are also storing its index, right? Now, what I told was, in order to choose a second element, you need to choose the maximum of the same flavor and different flavor, right? So here I am finding the maximum of the same flavor, right? So for that, what I need to do is I need to make sure that, right, its flavor should be same as that of the highest element, and it should not be equal to its index should not be equal to the maximum element, right? Because you may end up choosing the same element twice, right? And we don't want that to happen, right? So that's why I've written I not equal to index, and similarly I found the second maximum element of the same flavor, right? Then what we did was we also needed to find the maximum element of different flavor, right? Different than that of the highest, right? So again, we did the same thing, and here we just make sure that we are not choosing the element of the same flavor. That's why we have written f of I is not equal to f of index, right? So, and then at the last, we are just, if it is of the same flavor, then divide by 2, and if it is of different flavor, then directly taking it, and we are just taking the maximum of these two and returning it. Any doubt in the coding part, or in the code part, or any doubt in the logic part? Please unmute and just ask. So should we move forward?
So
Just anyone.
convert?
What?
Yeah. So how to convert our total idea into simple form of codes, sir? Can
How
you
to
please
convert?
step-by-step thought process behind that?
Okay, you are saying what was that thought process behind what?
Converting our ideas into code.
Okay, so converting ideas into, so this is a general question, right? Not specific to this question, right? Right? Hello?
Yes, sir.
Okay, so this is a so basically what we actually do is, like, let's say we got a logic, right? Like I decided like this should be the logic, right? Then what I do is I just stress test it. Like I take multiple test cases, and I just, because okay, you found a logic, right? Like let's say in this question we found that we need to choose the first maximum element, and then we need to choose the second element, right? And then in that case we need to choose if it is of the same flavor or different flavor, right? So I got that. Then what I do is I just confirm it with using multiple test cases. Start thinking like what could be the different edge cases involved, right? What could be the different edge cases? Once I am 100% sure that okay, it is working on each and every possible edge cases which I can think of, then uh, while creating different edge cases, right, I also think about all the if and else cases, right? So, and once like my logic is concrete, okay, so this is happening, then I have to do this, then I have to do this, then I just write it, while writing it, I just always think about the logic part, right? I think that could help. So we forgot to go with the
Breaking down into
second question.
simple problems.
Yeah, what?
Breaking down into simple problems and solving that problem alone at that time. After that, coming up that whole problem.
Yeah, that's also a very great point, like solving into small part. But since this was a small problem, so you can't do that much. But if there is a bigger problem, then yeah, basically we need to, as we will go to E and F, we will definitely see how it's working. Don't worry, right?
Oh, okay.
Breaking
Thank
into
you.
smaller parts, right?
Thanks.
Okay. So so let's go back to the B part. We skipped it. My mistake. So if we go to the B part, what it is saying is that a year consists of m months, and they have also given the number of days in each month, right? Now what they are saying is the number of days, the sum of all the month, right? Like say if the month 1 has 6 days, month 2 has 7 days, month 3 has, let's say, 7 days. So total 20 days, right? So what they are saying is, so they are saying that the total number of days is odd, right? So I can't take that, right? So let's say 6, 6, 6, 7, 7, and again 7, right? So let's say 27 days. So this is a valid. So they are saying that the number of days is odd. Now they are saying is what will be the middle day of the year, right? So let's say if there are 27 days in a year, then what will be the middle day? Can anyone tell me? Like let's say if there are 27 days in a year, what would be the middle day? Can just anyone unmute and tell me? Otherwise, I will proceed.
14.
Yeah, 14 will be the answer, right? And how did you find it? Because it is given that the sum is odd, right? So sum plus 1 by 2 would be the middle element, right? Let's say 27 is there, then 27 plus 1 by 2, 14. 14 is the mid, right? Let's take a small example, right? To make it concrete, right? Let's say if there are 3 days in a year. So 3 plus 1, 4, 4 by 2, 2, right? So 1, 2, 3. So 2 is the middle element, right? So they are also asking you, they have given you an array, and they are saying in which month will the middle day lie and what will be that day. They are just saying that question, right? So if we go by okay, so let's take a small example like this one. So they are saying 6 month 3 1 4 1 5 9, right? Now first step is to find the middle element, right? So middle day, what will be the middle day, right? So in order to find that, what we will do is just sum all sums, right? Because this is the number of days in month 1, month 2, month 3, month 4, month 5, month 6, right? So let's sum them all, right? So 3 plus 1 4, 4 and 4 8, 9, 18, 24, right? Sorry, 3 4 8 9 18 23, right? So sum is getting 23. So if we add by 2, so we know that 12th day is the mid day, right? Which we need to find in which month it lie and what is that, right? So if we start from counting from the first month, so 3 days has passed, right? So 9 days will be left after this, right? So 9 days would be left. Now if I go to the second month, one more day has passed, so we will be left with 8 days, right? Now again, like let's say I go to the third month, so it will say, okay, I have 4 elements and I need to get the 8th day, right? So it will again be not 8th day will not lie in this month also, and we will just reduce this 4 and we will be left with 4, right? Now I will go to the fourth month and I will say, is the 4th day lying? Does 4th day lie here? So it will again say, no, it does not lie, right? Because its value is 1, right? So we'll just deduct 1 and we will move ahead. So we will be left with 3. Then again, I will check, can 3 lie in this 5? So yeah, it can lie, right? So that's why it will be third day and 1, 2, 3, 4, 5, right? Of 5th month. So what we basically need to do is we just need to find the midday. Midday will be equal to sum plus 1 by 2 because sum is odd, right? And then what we need to do is just keep iterating over the elements of the array and just check, can the middle day lie in this array in this month? For example, let's again reiterate this example. So we were initially having these months, right? So what initially we needed 12, right? So we needed 12. So we will just check if can 12 lie in this 3? No, it can't lie, right? Because there are only 3, so 12 can't lie, right? So we will deduct these 3. So then we will be needing the 9th element, right? So again, I will go, okay, I need 9th element. Can it lie here? No, it will say it won't lie, right? So again, we will subtract this one and we will go here, right? And if we will go here, it will again ask, can it lie? It will say, no, it can't lie, right? Because its value is less than 8, right? So we will just deduct 4 and we will move here. Can it will say, can it lie? It will say, no, it can't lie, right? So 4 minus 1, 3. So it will say, can it lie? So yeah, its value is greater than 5 is greater than 3, right? So it can lie, right? And so if we I got to know, yeah, it can lie. So now since 5 will have 5 L in this, right? And we want the third, so it will definitely be the third only, right? So then I can say, okay, third and the I. So this is I equal to 1, this is 2, 3, 4, and 5, right? So third day of fifth month. This is how we will do this question. Is the logic clear to everyone?
Yes.
Okay, thank you. So if we go to the code part, basically a single for loop question. So first, as I told you, we need to find the midday, right? So we will just iterate over the array, right? And find the sum of all the elements, right? And after finding the sum, we will just add 1 and divide by 2, right? So it will give us the mid element. And then we will say, okay, can the mid element lie? So if its value is less than mid, then I can say that the mid element will not lie, right? And we will just subtract that. And let's say if we say, and if we found a month which is having more days as compared to our mid, our element, right, the required day. So I can say, yeah, it will lie, right? So we will just say, okay, so this is the month, and this is the its day, like which day it will lie, right? So this is the code. Any doubt in the coding part?
No, sir. Clear.
Okay, so let's go to the fifth question then. Uh, So the fifth question is saying that there are n books numbered from 1 to n, and the book I assumes that you have read CI books, and the Jth book is PIJ. So what it is saying is there are n books, and in order to read ith book, you are given certain books which you need to read first, right? So if you, for let's say if you need to read first book, they are given that you need to first read 2, 3, 4. Then let's say in order to read 2, they have given, okay, that you need to read 5 and 6, right? So the question is saying similar to that, right? So the question is saying that we need to read the first book. That's our foremost condition, that we should read the first book. And it is saying that now there is a given, right, like in order to read one first book you need to read some books, and in order to read second book you need to read some books. Let's say for third you also need to read those books, right? So it is saying that what is the minimum number of books you need to read beforehand in order to read the first book, right? So they are saying that, right? This is the question, and we need to print the order also. And they are saying if multiple answers can exist, then you can print any one of those. The question is that, is the question clear to everyone? First of all, okay, so I can take it as a yes, right? So let's let's go with this example first, right? Let's take this example and then try to figure out what the example was. 632. On 5. So the question is saying, okay, so if we look at the input 0, 1, 5, and 0. So it is saying that total 6 books are there, right? Now, in order to read first book, this is for the first book, this is for the second book, this is for the third book, this is for the fourth book, this is for the fifth book, right? So the question is saying, in order to read the first book, you need to read 3 books beforehand, which is 2, 3, and 4. Now, in order to read the second book, you need to read 2 books in advance. I think I have taken something wrong. 230 should not be a value. 235. Sorry. Okay. So it is saying, in order to read the second book, you need to read third and fifth book. In order to read the third book, there does not exist any prerequisite. In order to read fourth book, you need to read fifth book. So this is. So can anyone guess to which, yeah, you can understand that this is a graph question, right? So but like can like before whenever we see something like prerequisite, right, this thing depends on those thing depends on those things. So we one particular algorithm should come in your mind. Can anyone tell me what should it be? What? Can you repeat one second?
BFS.
BFS, when we talk about BFS, what BFS does is it do level order reversal, right?
No, I'm
What are the
saying
elements at this?
DFS. Depth
DFS.
first. Yeah.
Okay, so depth first search. Okay, but does because DFS is more of a general algorithm, right? Rather than focusing on prerequisite, right? Because it can be a directed graph, it can be an undirected graph. So what I'm making like, have you? Everyone is everyone know topological sorting, right?
Yeah.
Because this question is based on topological sorting, right? Can you say it loud? What you were saying?
Yes, your topological sort yaad aa gayi.
Okay, yeah. So in topological sort, actually it happens, right? We make in edges, right, and then we relax them, right? So this question should, because whenever you see dependencies, right, prerequisite terms, dependency terms, so you should always consider topological sort. Once you should just give it a try, right? So if we draw, like, let's draw the graph also, and then things will get more clear, right? So what it is saying, for the one, you should first read book 2, book 3, and book 4, right? For the second book, you should read 3, and you should read 5, right? And for the fourth book, you should read 5, right? So this is the graph, right? For the first book, 3 dependencies. For the second book, 2 dependencies. And for the fourth book, 1 dependency, right? So it is saying that if you need to read 1, you need to first read 2, 3, 4. If you need to read 2, if you need to read 5, right? So we got, okay. So some may think, okay, then it's a direct topological question, right? First I will go to 5, right? Because its in edge is 0, right? This guy has in edge equal to 2. Let me change the color. So number of in edge of this is 0. In edge is 2. This in edge is equal to 0. In edge is equal to 1, and in edge is equal to 3, right? So if we recall from the topological sort, what we do is we just push all those elements which have in edge equal to 0 in the queue, and then we visit them, and all those edges or all those nodes which it is pointing. So for example, if we push 5 inside the queue, so 5 is pointing to 2, right? So we will decrease its in edge by 1. We will decrease force in edge also by 1, right? So its in edge will become 0, its in edge will become 1, right? And then again, if it becomes 0, then we will again push it. So one by one, this thing happens, right? So on the first look, you may seem that, okay, this is just a simple topological question, right? Topological sorting question. First 5 will be visited. So, and it says that multiple answer can exist. So this also helps, right? Because it could have possible, right? You could have chosen 3 first, because it also has 0 in edges, and 5 also have 0 in edges, right? So anything 3 or 5, anything could have been chosen, right? So let's say we choose 5 first. So then 5 would be chosen. Then let's say 3 would be chosen. Then, okay. So let's say you choose 5 first. Then what you will do is you will decrease the in edge by 1, right? Here, and you will decrease the in edge by 1, 0, right? Now 3 will be chosen, and it will again decrease the in edge by 1, and again decrease the in edge by 1. So we have done 5, we have done 3, 4 will be pushed, right? And 2 will also be pushed. This 4 also has 0 in edges. 4 will also be pushed, and 2 will also be pushed, right? Now 2 will decrease its in edge by 1, and 3 will also, sorry, 4 will also decrease in edge by 1, right? So 5, 4, 4, 2, and then 1 will be chosen, right? So this could be a order, right? Now, basically, this could be a question, right? So you could, if you don't think of all the edge cases clearly, you could end up giving this as the answer, just the topological part, right? This could happen, right? Any doubt till now, right? You can say that this could be an answer, right? If minimum is not set, right? But here the question says that you need to find the shortest one, right? These should, okay, so here it is the shortest, but it can happen that something else can also happen, right? Let's say what can happen is, let's say there exists, apart from this component, let's say there exists another component, right? And what it is doing is, it is saying that, okay, 7 depends on 8. Let's say something like this is happening. And let's say line also depends on this, right? So we don't, so if you go with the traditional topological sorting, you will also push, because it also has 0 in edges and this also has 0 in edges, right? So what you will do by mistake is, you will just take these also into consideration while considering your answer. But we don't need to take these, right? Because it has nothing to do with one, so why should we take them, right? Why should we concerned about them, right? Are you getting why we won't be pushing this 8 and 9 into Q? Just tell me if this part is clear or not. Hello.
Yes, sir. It is clear.
Okay, clear. Okay. Yeah. So yeah, so we discussed. Okay, so if this guy has, if this node 7, this 8, this node 9 has no business with 1, then we shouldn't use them in the topological sorting, right? Because they will just add up, right? They will just make our answer bigger, right? We don't, 7 should not be read, right? 7 is not a prerequisite of 1, right? 8 is not a prerequisite of 9, 1, right? 9 is not a prerequisite, right? So why we should? So any other connected component should be avoided, right? Similarly, let's say 1 is a prerequisite of, let's say, 10. So do we need to consider this 10? No, right? Because 1 is prerequisite of 10, right? 10 is not a prerequisite of 1, right? So why we should consider? Similarly, let's say 4 is a prerequisite of, let's say, 11. So should we consider 11 also? I will say no. Why will we consider 11, right? Because for 11, you need to know 4. But why 11, right? Why will we don't need, we need to find the answer for 1, right? We need to make sure that 1 has to be right? We don't have to make sure that 11 has to right? So if there exists, like, let's say if for 11, 4 is prerequisite. So we should not be considered about this, right? We should not consider this 10 also, right? So we need to, okay, so we are, so by saying this, what I'm saying is, we need to apply topological sorting, that's true. But selective topological sorting, right? Not traditional topological sorting. We just need to remove those some nodes, and then we need to apply, right? So now the question is, how will you do that, right? So now, in order to do that, what we will do is, if you will observe, let's say, if I would have created an opposite graph, instead of 2 pointing to 1, if I had created this, let's say, let's create one opposite graph, right? Anti graph, you can say. So if we, so directed, undirected, okay, I should not use undirected, but I mean here referring undirected means opposite graph, right? So if I would have created opposite graph, right, and not these edges, let's remove these edges, and let's say if I had created another graph, right? If I would have created another graph which has opposite edges, right? So I think we have made it pretty messy. So let me draw the graph once again. So should I increase the font, right?
It is clear.
Okay. So what I'm saying is, like, let's draw the graph once again. So 1, and let's draw the opposite one graph, right? Because we had a previous graph also, and let's draw the opposite of it. So 1, and opposite is 2, opposite is 3, opposite is 4, opposite is 5, opposite is 6, right? And opposite is 3, right? And similarly, this will also get opposite, so this will become 10. This will become 11. And let's, if we talk about these two, 8, 9, 7, right? So this is again opposite and this is also opposite, right? So if we look at this graph, you will notice which first of all, if you go back, what edge cases, when we were discussing the edge cases, we said that we need to avoid this one, we need to avoid this one, and we need to avoid these all, right? Because they have no role in one to play, right? So okay, so what I'm saying is, like, let's say if we start DFS from 1, then what all nodes will be visited? 1 will be visited, 2 will be visited, 3 will be visited, 4 will be visited, 5 will be visited. Will ever 11 be visited? No. Will, if I start DFS just by 1 and not anyone else, right? 10 will be visited? No. Will 7 be visited? No. Will 8 be visited? No. Will 9 be visited? No. So we got all those points, right? All those nodes which should be visited, right? So I am saying, okay, so basically what I am saying is, first let's reverse the graph, then find all those nodes which could be visited by 1, right? Why I am saying is, all those nodes which could be visited by 1 will only be the prerequisite actually, right? That's the point, right? Because here, let's say if I go, if we see this 11, so 4 is the prerequisite of 11, right? And it has nothing, no business with 1, right? That's why when I was doing DFS in reversed order, in reverse graph, it never came, right? Because it has nothing to do with 1. All those people who has something to do with 1 will be visited when we call DFS from 1, and all those who does not have any business will not be visited, right? So what I'm saying is, just reverse the graph. Let's run the DFS and find all those nodes which are actually needed. Once we found all those nodes, then just apply the topological sort in them, and then all the unnecessary things will never come in your answer. So this is the algorithm part, how we will any doubt in the logic part.
Clear.
Everyone is clear, right? Because this you can say modification of topological sorting, right? One other way of thinking, or modification of the topological sorting. So if anyone have any sort of doubt, you can ask. Like, how many of you were able to do this question during the contest? Okay, -1. Okay. Yeah, so yeah, you can consider this as a difficult question, right? Because around, I don't remember the exact number, but yeah, submissions were less, right? And most of the people would have stick on D question, right? Because D was more difficult as compared to E, right? Yeah. So I guess everyone is clear with the logic, right? If anyone is not clear, just ask me once again, right? I will explain it again. I guess everyone is clear then, right? So let's go to the code part then, right? So I told you that we will be creating one the regular graph which is supposed to be made, and one the reverse graph, right? So that we can apply DFS from 1, right? So I was in a hurry during the contest, so I referred it as undirected. This is the reverse. This is not an undirected graph. This is just a reverse graph, right? Okay. So as you can see, while I was creating the directed one, I was just pushing, and undirected is just opposite of it, right? So I am creating a normal graph and a reverse graph. You can just rename it undirected to a reverse graph, right? So I'm creating two graphs. One is just the directed one, and one is the another undirected graph, right? And I told you what we will do is, we will run DFS from 1 in reversed graph, right? And we will mark all the nodes which we need for 1 as visited, right? This was our approach. This was the first part. Someone told how to break the question into multiple parts, right? And small parts. So first one is, we need to find all those relevant nodes which are actually the prerequisite of 1. How we will do it? We will just reverse the graph and we will start the DFS from 1. This will be the part 1. So what I did was I had also, as you will observe, because I need to do the topological sorting also, right? So that's why I have taken in edge of I++, right? So I'm just taking the in edge also. This could have be done in the later part also, but still I'm doing it in the initial part only because we were running a for loop, so why waste it, right? So yeah. So what I did is I just ran a DFS from node 1 in the reverse graph, right? And I'm just marking all those which will be visited, right? So first marking the node as visited and just then calling all its unvisited child. So at the end of this DFS, what we will be having is we will be having all those. What we will be having, we will be actually be having only 1, 2, 3, 4, 5 having visited value as equal to 1, and all other 7, 8, 9, 11 and 10 will have its visited value 0. These will be the visited value, right? These will be. So now what I'm saying is we will just apply the topological sort in this part, right? Because these are visited, right? We will just check if whenever we will get a node, we will say, okay, do you have your visited value equal to 1? If it has its visited value equal to 1, then we will only go for it, right? So basically this is the part, right? So yeah, so we have reached till here, right? Now we all have all the visited, right? All the nodes which we need. Then I'm just applying the traditional topological sorting. What I'm saying, if in edge is equal to 0, and if it is visited, then push it into queue. Then what we do is we just pop from the queue. And since this will also be a part of the answer, right? It will be a part of the answer. So we will be pushing it, right? In the order in which it is coming, we will just take we'll just take a vector and we will be pushing it because we need to return the order, right? So we are pushing it into the array. And now, then what we will do is, this is just a normal topological sort question. What we do is we just, okay, we pop an element, and then what we will do is we just visit all its adjacent elements and we will just decrease their in edge. So we have decreased their in edge, and if at any point in edge is equal to 0, and if it is visited, you need to check this visited part, right? I was checking here also visited part, in this part also, and I'm checking visited part here also, right? So if the visited part is true, if it is visited, or you can say we need to mind its business. And if its in edge is 0, we are pushing it into queue again, right? So by this, if you will do this, we will get a topological order and the question will be solved. Is it clear to everyone? Just anyone please unmute and tell me, like, is it clear or any doubt? Feel free.
No doubt.
Okay, no doubt. Got it. Okay. So now let's go to the F question. Right. So was anyone able to solve this F question? Just give a yes or no. Okay, no. Yeah, this was a tough question, but like, because if you will see it's constrained, you will say, okay, it's not possible. But there was a hidden logic behind it, right? That's why this is interesting. If they would have given you small, okay, so everyone is familiar with DP, right? Dynamic programming, right? For people like who are saying no, the prerequisite for this question is dynamic programming, right? So that could be because this is an app question, so that can be an issue. So those who know dynamic programming, so they know basic knapsack problem, right? Yes or no, like take or not take or not take or not take condition, right? We usually do, right? That's the first standard question we usually do in DP, right? We have two options, either take that element or not take it, take the element or not take it, right? So basically this question is just that question. but they have framed it beautifully and they have played with the constraint so beautifully that we are not able to decode that this is the same question. Just that's the difference, right? So let's just read it once and you will get to know it. So what it is saying is there are endpoints in a there are endpoints in a race, right? So first point, then second point, then third point, then fourth point, fifth point, sixth point, up to nth point, right? Now, and they are in order, right? So first you need to visit one because normally what the race is, first checkpoint, then second point, checkpoint, then you can take rest, something like that, right? So they have to be visited in order, right? First you need to visit the first checkpoint, then the second, then the third, then the fourth, then the fifth, and up to the nth checkpoint, right? Now, what basically it is saying that every checkpoint has some coordinate which is different, right? Everyone has a unique coordinate, right? Now they are saying that other than 1 and n, the first starting point and the ending checkpoint, another you can't skip these two. Leaving aside these two, you can skip any one of them, right? So let's say you decided to skip 2, then 4th, then 7th, then 9th. Let's say you decided to skip these 4 elements, right? So like let's say you need to go to 10, 1 to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And what they are saying is you can skip anyone except 1 and 10. Let's say you decided to skip 2, 4, 8, 9. 2, 4, 8, 9, you decided to skip, right? So in that case, total number of elements skipped will be 4, right? So it is saying that the number of checkpoints which you have skipped, if it is equal to, okay, so number of checkpoints, they are denoting as C. Number of checkpoints which you have skipped, they are denoting it as C. So they are saying now you will need to add this to keep 2 to the power C minus 1 to n. So let's say if you skip 2 checkpoints, then you need to add 2 to the power 1. Let's say if you skip 4 checkpoints, then you need to add 2 to the power 3 to your answer, right? Similarly, if no checkpoints are skipped, then 0, right? And so, and then what they are saying is the answer will be total distance traveled from first checkpoint to the nth checkpoint plus this penalty, which we were saying that 2 to the power C minus 1, right? This is the penalty, right? So yeah, I got it. Like it will not be clear right now. So let me explain it once again. So what they are saying is, okay, and well, first of all, before going, let's look at the constraint also. So they are saying xi comma yi can be anywhere from 0 to 10 to the power 4, right? So this is, let's pay attention. And the number of element is also equal to 10 to the power 4. And it's equal to 10 to the power 4. And what they are saying is xi comma yi can range here, right? And what they are saying is there are n points, right? Let's say 1 point, 2 point, 3 point, 4 point, 5 point, 6 point. Total 6 points are there, right? And you can skip some points. So let's say you decided to skip 3 and 5. So what will be your distance will be? Distance between 1 and 2. Then since you skipped 3, so distance between 2 and 4. Since you skipped 5, then distance between 4 and 6. You can find the Euclidean distance, right? Euclidean distance formula is x2 minus x1 square plus y2 minus y1 square under root, right? So they are saying this will be your distance. And since you have skipped 2, right? So this will have a penalty. So what the penalty will be? Penalty will be 2 to the power 2 minus 1, which is equal to 2, right? So this will be the penalty and this will be the distance. We need to find such a way that we minimize this sum. Is the question clear to everyone? You are given n points, you can skip some. And if let's say you skip 2 points, then we need to calculate the distance between the remaining. They have to be in order, right? You can't mess up the order, right? 4 cannot come before 2, right? So what they are saying, 1 to 2, 2 to 4, 4 to 6, right? We will calculate the distance. And once we calculate the distance, we know, okay, we have skipped 2. So we will be adding 2 to the power 2 minus 1. It could have been possible that you don't skip anyone, right? But anything can happen, right? So they are saying, so this is the question. So is the question clear to everyone? We need to minimize this distance plus penalty, right? Just give it a node. Is it the question? Yeah, so Akash is saying the question is clear, right? So, okay. I guess question is clear to you, right? So let's not consider the constraint part. Okay, so first of all, since xi comma yi can be anywhere between 0 to 10 to the power 4, so as you can see, this lies till 10 to the power 4, and number of column is also lies to 10 to the power 4, right? 1 can be here, 2 can be here, 3 can be here. Let's say 1 can be here, 2 can be here, 3 can be here, 4 can be here, 5 can be here, and 6 can be here, right? So if we decide, okay, we are not skipping anyone. So what you will do is you will go from here to here, then you will go here to here, then you will go here, and you will go here, and you will go here, right? Let's say you decided to skip 3 and 5. Then what will be your path? Your path will be 1 to 2, then skip 2, so 2 to the power 2 to 4, then skip 5, 2 to the power 6. But in that case, apart from this distance, you need to add 2 to the power 2 minus 1 to your answer, right? So if you look carefully, what the question is saying is take it or not take it. When I need to take 1, that's for sure. I need to take 6, that's for sure, right? Now, who is left? 2 is left, 3 is left, 4 is left, 5 is left, and 6 is left, right? So, sorry, 2, 3, 4, 5, 4 contenders are left. I will say I have 2 choices. Take it, not take it. 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 Right? I have these choices, right? But okay, now okay, I'm since we are trying to make a brute force solution right now, and we are not concerned about the constraint. So if that is the part, right? So in that case, I think this question could be solved using brute force. What you will do, or you can say DP also. Let's optimize DP. What you will do is, since this question is only take it, not take it, take it, not take it, right? So we know that okay, 1 has to be taken. So we will start from 2. Let's say if you decided to take it, then what you will do is you are also storing the last element which I have taken. What we are storing is current element and the last element. All right, let's say we are doing this. We are storing, we are keeping DP state as current element and the last element, and we also need to keep a count of skipped. How many elements we have skipped if we are making this state. So what we are doing is, let's say if I reach 2, then I have 2, right? Let's make it, let's write it here. 1, 2, 3, 4, 5, and 6, right? 1 and 6 are constant. Now, when I reach 2, I have 2 conditions, right? Either take it or not take it, right? Let's say if I take it, right? Then what will happen is I need to add the distance, right? What is the distance? So then I need to add distance of 1, 2. What is the distance between 1, 2? Right? And then my last element, the current element, then I will go to 3, right? So I will say, okay, we will go to 3. And what we will say, the last element will now become 2, right? Because I have taken it, right? And since skipped was initially 0, now the skipped will become 1, right? Similarly, you will say, okay, let's not take it. If you say not take it, then what will happen? We don't need to take a distance term, right? Because we are not taking that element. Since 2 is being skipped, then no need, right? So what we will do is we will just call solve. And what we will do is we will go to 2, right? Sorry, we will be going to 3 only. But this time, since we have not taken 2, so we want to be considering it into last element, right? And one more mistake which I did was I need to take 0 skipped element, right? Because we took the second. We need to take the first element, and we are taking the second element, right? So the skipped still remains 0. But when we decide, okay, we are not going to take it, then the number of skipped element will become 1, right? So we just need to take the minimum of these two, right? Right. We just need to take the minimum of these two. It's just simple. Take it or not take it. Like, let's say if I take it, then I need to add distance of 1, 2, and then call next, right? What could be the answer of the later part, right? So in that case, the current element will be same, in the next element will be same, right? But now if you are taking it, then the last element will become the current element, right? 2. And if I am not taking it, the last element will become 1, right? Because I am not taking 2, so 1 will be, right? And the number of skipped will also become 1, right? Similarly, if we go by 3, if you talk about 3, then again, similar, like let's say we reached 3 and we reached from, let's say this state, right? In which it is saying that you are at current element 1, the last element which you visited was 1 and you have skipped 1 element. Now 3 will again have 2 choices, right? Either take it and not take it. Let's say if I decide to take it, then what will it say? You need to, if you take it, then you need to complete the distance between the last element and the current element, right? So distance between 1, 3. And then what we will do is we will go, okay, you had done till 3. So let's go to 4. And now the last visited element will be 3. And the skip still remains 1, right? Because you haven't skipped. And let's say if you don't skip it, then you don't, if you skip it, you don't take it. If you say I'm skipping it, then what we will do is, okay, I'm skipping it, so no need to add the answer. We will go to 4. We will say, okay, since you are skipping it, the last element still remains 1, right? This will be the same. And now the number of skip element will become 2, right? This is what I'm going to do, right? And at the end, when I reach the last element, let's say if I reach the last element, sorry. So let's say if I reach the last element, or you can say if I equal n, let's say if I reach the last element, so what we will do is, we have a last visited element, right? We have a count of skipped element, right? And the current. So current will always be equal to n, right? So what we will do is, okay, you can't skip n, right? So in that case, what you will do is, you will just add the distance of last visited, comma n, plus 2 to the power skipped minus 1, right? You will do this, right? So if you look, if you go by the DP, and if you memorize this, you decide to memorize it, then if you talk about the time complexity, since in DP state what you are storing is, you are storing the index, you are storing the last element index, right? And you are storing the skipped, right? So in the worst case scenario, this can be of n, this can be of n, and this can be of n. So you may end up having n cube code, right? Which could be equal to 10 to the power 12, right? So yeah, this will give TLE, but this basic DP approach clear to everyone? I'm just doing take it or not taken, and based on that, I'm just writing the, is this approach clear to everyone? Yeah, this may be brute force, but is it clear to everyone? It's clear. Okay.
Excuse me, am I audible?
Yeah, you are audible.
So I'm having doubt that you are taking 3 states and the last state is skipped. So I was thinking to take the last state as the penalty. Would it be right?
So what? Okay. Now penalty, you mean 2 to the power skipped minus 1, right?
Yes, yes.
Okay. So in that case, what you would be doing? Okay. So when I would be creating a DP thing, so here what I write was, okay, this will take O of n, right? This will take O of n space, and if we talk about the space complexity also, so this is taking n, and n, right? So space complexity will also be n cube, and the time complexity and space complexity is also n cube. Now, if you go with that thing, if you go with the penalty, then what you will store is, then you will store 2 to the power n minus 1, right? In the worst case, right? N minus 2, basically, because you can't skip 1 and 2. So in the worst case, 2 to the power n minus 2 can also come, right? So are you getting? You would be increasing your space complexity to 2 to the power n minus 2 n minus 1, right? That's why I am not taking that. Yeah, you can say okay, but yeah.
I am asking that if we will not consider this space complexity, then will it give us the correct answer?
Yeah, it will give you the correct answer because it's just a basic manner of storing that, right? Only, right? But actually, what will happen with that thing also is, let's say I decided here, what I did was in this part. Yeah. So here what I did was I had completed the first element and I was at second element, right? So we had two choices, either to take it and not take it, right? So here, instead of writing 1, what you will write is, you will write 2 to the power 2 minus 1, right? You are seeing that, right?
Yes, yes.
And then what you will do is, here also you decided not, if you decided not to take it, then you will write 2 to the power 2 minus 1, right? Right.
Yes.
Yeah. So now here what I did was, since then it will be having 2 to the power 0, and from going from here to here, then what you will again need to do, you will again need to find which power it was and then increment that power, right? Because you are having 2 to the power 2, right? Then how will you get to know that now I have to write 2 to the power 1? So in that case also you need to find which power it is, right?
Yes, I've
Are
got
you
it.
getting my point, what I'm saying? Yeah,
Yes, I
so
got
that will also an issue. Yeah, so that's
Maybe
why.
I have
And
to increase. It's maybe the case that I have to include one more state for that last power.
you can, but yeah, you can have it, but you can also find it in log n time, right? Also, right? That could also be done, right?
Okay.
You are given a number,
Yes.
find the power, right? You can do it, right? So I think you don't need to take another state for that. But yeah, so basically this dpn cube solution is clear to everyone or not? I guess it is, no one is saying no. So yeah, I guess I'm taking it as a yes. So now we need to optimize it, right? So what I was saying is, if so our question has two factors, right, in it. If you look, one is the distance factor, and another is the penalty part, right? And penalty is basically 2 to the power skipped minus 1, right? And how this distance part is calculated is, you are given some point, like let's say 1 is here, 2 is here, 3 is here, 4 is here, 5 is here, 6 is here. Let's say you decided to skip this 4. So then in that case, what you will do is 1 to 2, 3 to, right? And you are computing this distance, right? So I am saying is, and this can be of size 10 to the power 4. This could be of 10 to the power 4. So if I want to have a rough estimate of what could be the maximum value of distances, any case, let's take the worst case. I'm just taking, okay, I'm not going to the exact thing. I'm just saying, okay, what could be the maximum answer in worst case? I will say, okay, since this is 10 to the power 4 grade is, I will say, okay, let's not waste any right? We will say, okay, worst can be 10 to the power 8. Yeah, you will say, okay, it will be less than 8. Okay, but I am saying the answer will never be greater than 2 to the power 8, right? The distance part, right? Is this clear to everyone? You decided to go from, in the worst case, what you will do is you will choose everyone, each and every road, right? You won't skip anyone, right? So in that case also, you will be getting the worst answer, right? So I'm saying is the worst answer can never be greater than 10 to the power 8, right? Because total cells are only 10 to the power 8, right? So how will this be more than, right? That, right? Is this part clear to everyone? Just anyone unmute and say yes or no. Yeah, okay. This is clear, right? Okay. And so this is 10 to the power 8, right? Somewhat. Okay. Now, if we talk about this thing, what I'm saying is, let's say if you skipped 30 checkpoints, let's say if you skipped 30 checkpoints, or let's say if you skipped 31 checkpoints, for example. If I skipped 31 checkpoints, in that case, what will happen is, it will give you a value of 2 to the power 30, right? This will give you a penalty of 2 to the power 30, which is approximately 10 to the power 9, right? So what I am what I want to make it clear is, if you go here, if you see the distance part, it can never cross 10 to the power 8, right? If we and how will the distance will decrease? You need to take more skip more elements, right? In the worst case, when skip will be 0, in that case the maximum distance will come, and that distance will be equal to 10 to the power 8. Similarly, what I am saying is, now if you increase the number of elements skipped, so your distance will go down, right? What I am saying is, it will go to a limit. Let's say you decided to skip 31 checkpoints. In that case, that penalty part will exceed 10 to the power 9, right? So then why will you choose it? Because I am saying is, if you are choosing 0 checkpoints, then in that case your maximum answer can be 10 to the power 8. And I am saying, if you choose more than 30 checkpoints, in that case your answer will definitely greater than 10 to the power 9. So why will you choose more than 30? Right? You will never choose more than 30. Right? We will always stick to less than or equal to 30. Right? And if at any instant my number of skip becomes greater than 30, what I will say is just return 1E9. Or you can say don't take it. I'm just taking that, okay, we won't be moving forward. Is this logic clear to everyone?
Yes.
Yeah. So then what I will say is, then in that case, what will happen is, your initial complexity was what? What you were checking was current element. Then you were storing the last visited one, or you can say not skipped one, and you were storing the total number of skipped element, right? So now I told you that this will never be greater than 30. If you take greater than 30, then don't take it. If you are skipping more than 30 elements, then no need to take this part, right? Because if you are taking more than 30, then your answer will always be greater than 10 to the power 9, right? So now if I remove this part, okay, so now this has become 30. So now our code has become n square into 30 watt. This will also not run, right? So again, I can't skip this current part, so I need to find a way to get the skipped part very quickly, or the last visited element very quickly. So for that, what I will do is, what I'm suggesting is, let's keep the store of how many I have skipped continuously since last visited checkpoint. What I'm saying is, let's say you have 1, 2, 3, 4, 5, 6, and 7. 1 is necessary, 7 is necessary. Let's say you decided to take 2, then you skipped 3, then you skipped 4. If you are at 5, what I am saying is, let's say, since you have skipped 2 continuously, right? So I'm saying, store this 2. Let's say you skipped 3 also. Then in that case, I'm saying is, last continuously skipped. This was the last visited element. So from the last visited element, how many you have continuously skipped? I'm saying let's store that. So why I'm doing this is because I'm saying is, let's say you have skipped continuously 3 elements since the last visit. Then I know that if I am at 5, and if you have skipped 3 elements from back, right? From then I can just, what I will do is, I will just subtract 3 my n plus 1, 4, right? Because 3 have been skipped and 1 more, right? Because in 1 you will go here, then here, and then here. So you need to decrement 1 more, right? So if you remove 4 from it, you will get 1. This will give me the last visited, right? Let's take a bigger example. It will become more clear. Okay. Let's say we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So let's say I decided to skip 3, then I decided to skip 4 and 5, and let's say I decided to skip 8, 9, 10. I am taking, let's say I'm taking 1, 2, 4, 7, 11, and 12. So what I am saying is, if you reach 7 and you have decided to take 7, in that case, the number of last skipped will be 2 for you, right? For 4, it will be 1, right? And for 11, it will be last continuous skipped before taking 7 will be 3, right? So if I'm storing this thing, then if I want to know what was the last visited element, what I can do is just write 11 minus 3 minus 1, right? So this will give me 7. Similarly, if I know what was the last skipped element from 7, I will do 7 minus 2 minus 1, right? This will give me 4. So what I am saying is, let's store how many continuously elements you have skipped. So this will help me get the last element visited. And if I talk about what will be its maximum value. So its maximum value will be, so if we talk about what will be its maximum value, in that case, its maximum value will be equal to 30 only, right? Because what I am saying is, if you are skipping 30 elements in total, so how many maximum can you skip in the last part, right? It can never exceed 30, right? Because if you are skipping 30 elements in total, and I'm saying is, since last visit, how many have you skipped? So it can't exceed 30, right? So it will also be 30 only, right? So now, if that is also 30, then my code becomes n equal to 30 into 30, right? Actually, it was actually n into 28 into 28 or n into 29 into 29, because I was taking 10 to the power 9, but maximum value can be 10 to the power 8, right? So that's why in the coding part, I took it n into 29 into 29 most probably, right? So by doing this, we have restricted our code to n into 30 into 30. So let's take back now. Let's go back to the take and not take code once again. Is everything clear till now? Or is it getting too much now? Is it clear? Can anyone respond? Is it clear or not till now?
Explain the
Okay,
last part
then.
once more.
Okay. So what I was saying is, initially what you were storing was the current element, right? And which current index are you? Let me increase. Right. So what you were actually storing was the current element. Because let's say if I decided to take a particular element, then I need to know, right, what was the last visited element, so that I can calculate the distance between those, right? So I was storing the last visited one, or you can say not skipped, and I was storing the skipped part, right? How many I have skipped. So what I was saying is, this can not exceed 30, right? This is of n. So I needed a way to find this last visited one, right? I cannot store direct indexes, right? Then the space complexity will be n into 30, right? So what I decided was, I decided to take a variable which will store how many I have skipped since last visit. Since the total skip cannot exceed 30, so how many I have skipped since last checkpoint cannot exceed 30, right? So instead of storing this last visit, what I'm storing is how many skipped since last visit. So if I have know this, then I can find the last visit. It will be equal to current minus this value minus 1. I'm doing this. Is it clear?
Yes, clear.
Yeah. So this will also take 30 only, right? So the code will be n into 30 into 30. And now let's do one thing. Let's say you have 1, 2, 3, 4, 5. If you have to take 1. Now, if you are at 2, right? and you decided to skip this 2. So in that case, what you will store in that case is, let's say you decided to skip 2. Okay, so first take, if you decided to take it. Now, if I take it, then I need to take the distance between 1, 2, right? Okay. And okay. Now, how will I get 2, right? Because if you started from 2 only, so currently the number of skipped elements, you are at 2, number of skipped element is 0, and the total skipped element is also 0, right? So if I want, so I need to, so the last skipped element is also equal to 0, right? So now if I decide to take this element, so what I will do is I will write the distance between 2, 2 minus this 0 minus 1, right? Which will actually give me 1, right? And since you decided to take it, the number of skipped element will be 0 only, right? But let's say, and you will write, okay, so here it comes, sorry, because we are storing the distance here, right? And if we talk about the score part, since you decided, you found the distance between the current and the last visit, and you are deciding, okay, I'm taking it. So in that case, since last visited, the number of elements skipped will become 0, right? And the total skipped is also 0. And now the current element will become 3, right? And let's say if you decided not to take it, you decided that. In that case, what will happen is, we don't need to add the distance part. It will be 0 because I'm skipping it, right? And since if I am skipping it, then when I will go to the next element, I have skipped one element from the last visited, and my total skipped is also 1, right? So by doing that, it will be updated, right? Is it clear? Hello, is it clear?
Clear.
Oh. So if we go to the coding part, so I have taken 10 to the power 10 into 29 into 29, because we had discussed that you could have taken 30 also, but if you go more into details, then 10 to the power 29 is also less than is also greater than 10 to the power 8, right? That's why I'm taking it at 29, right? So I'm just, since we were also calculating the equality distance, so we need to return answer in double, right? So that's why if you see, I had taken the data type of DP as double, right? And what I'm doing is I'm initializing it with minus 1.0, right? Usually what we do is we write minus 1, right? Because since it was double, so I write minus 1.0. No difference in that. And I'm just storing the coordinates point, and I'm just, because we can't skip the first elements, that I have taken everything as zero-based indexing, but since we can't skip the first element, that's why I have started with 1, right? And in our DP, what I'm saying is, okay, so let's say my last skip, I know that how many I have skipped in the last iteration. Since last visit, how many I have skipped. So the last visited element can be calculated using that formula only, I minus skip minus 1, right? Which we discussed, right? So what I am saying is, let's say if my skip is greater than 27, actually, because why I'm writing it as greater than 27, because I calculated that if you compute 2 to the power 28, it is also greater than 10 to the power 8. That's why I wrote it directly here. I wanted to optimize it more further, but if you could have taken 30 also, that would also work well, right? So it is saying that if your skip is greater than 27, then just return 1 because we won't be going with it, right? That's right. And now again, what I'm saying is, like, let's say if your I is equal to n minus 1, or you can say if I'm at the ith element, then what I will do is, if, like, let's say if I haven't skipped any element, then I will just take the distance between the current element and the last element, right? But if let's say I have skipped some element, then I will go to this part and I will then add the penalty of that also, right? Now here I'm just checking if this state has been visited. You generally check not equal to -1, right? I'm just taking it because it was double. I didn't want it to go into much precision issue. That's why I just wrote if it is greater than equal to 0 or not, right? Because if I am getting an answer, it will definitely be, since all the coordinates were distinct, so it will always be greater than equal to 0, right? Then I am just writing take it or not take it. Let's say if I decided to take it, in that case, my last skip will become 0, right? Because how many elements have you skipped since last? Will be 0, right? Because I am taking the current element, right? So it will become 0, and skip count will not increase, and I will just go to I plus 1, and I just find the distance between the current element and the last element. But I decided not to take it. In that case, my number of skip will increase by 1, and my last skip will also increase by 1, right? What if I'm continuing it, right? And then just I'm taking the minimum of it and I'm storing it in DP. Is this clear to everyone?
Clear.
Okay, and everyone who is watching, please do fill the feedback form available in the comment section. And I think we will be ending it here only. We won't be discussing the question. Any doubt in any question, whichever we have discussed, A, B, C, E, F. Any doubt? No. Okay, then we would be ending.